So Descartes' rule of signs. So it asks to describe the real zeros. So we do this by looking at the change in the signs. So we have a question, g of x, so we have a function minus 3x cubed plus 2x squared minus x minus 1. So we have to look at two versions. So we look at the g of x, and then we look at the g of the minus x. So on the first one, the g of the x, if we look at when the signs change, so we change from a negative to a positive, and then we change from a positive to a negative. So we have two sign changes. Now, the possibility of positive and negative, and we have imaginary. So you always have a conjugate when you have an imaginary number. So it means that we could have 2 or 0 real roots, because 2 could be imaginary. So we have two sign changes there. And let's have a look at the negative. So this is minus. It's going to change all the x's to minus x. And then we're going to see how many sign changes that we actually have. So minus x cubed, this is going to be a minus, and then it's multiplied by a minus, so that becomes a positive. So minus x squared becomes positive, so this is going to be a positive. And then minus x is positive, so that's plus x, and that's minus 1. So that means that we have 0 sign changes. And then here we have a positive to a negative, so this is a positive to a negative, so we actually have just 1 sign change. So we can't have a negative amount of roots, so this means that we have, when it's negative, we have a possible 1. So a positive roots could be 2 or 0, and negative could be 1. Now if we were to draw a table for this value, so we said the positive roots, negative roots, or zeros, imaginary, and the total. So this is power 3. So the total roots that we could have is going to be 3. And we said we could have either 2 positive or no positive. And we said we'd have 1 negative. So if you have 2 positives and 1 negative, that's a total of 3, so we can't have any imaginary. But if we had 0 positive, we'd have 1 negative, we'd have 2 imaginary roots. So in our case here, so if we put our graph into Desmos, we can see that we have a negative 0 near to minus 0.5 and no other rational zeros. So we didn't have any positive roots, so there was no positive, there was 1 negative, which means we would have 2 imaginary roots to total to 3. So a guided practice question. Describe the possible real zeros of each function. So we got the function 6x to the 5 plus 8x squared minus 10x minus 15. So we need to look at the positive. So we're looking at 1 from positive to negative, and there's no other root changes, positive to negative, negative to positive changes, just the one. So there's only one positive root, or 0. And then we need to look at if it was negative. So we're looking at h of negative x. So 6 to the minus x to the 5 plus 8 to the minus x squared minus 10 to the minus x minus 15. So minus x to the 5, that's going to be odd, so we're going to have minus x to the 5. X squared will be positive, so this is going to be a plus x squared. And we've got a minus times a minus, which is going to be a positive. And then we have minus 15. So the root, the positives to negatives, we just have 1. So 1 from positive to negative, and we have 1 here at the beginning. So this is from negative to positive. So that is, when it's negative, we're going to have 2 possible negative roots. So if we were to put this into a table, we have 5 possible roots. So the positive roots, the negative roots, imaginary roots, and the total. So there's a total of 5. So if we had 2 negative and we had 1 positive, so that's 3. So that means we must have 2 imaginary roots. Or if we had 2 negatives or 0, okay, so if we got 2 negatives, or we could have 0, which means we would have 2 imaginary roots, or we could have 4 imaginary roots. So this would be, if we've only got 2 or 0, let's get rid of that. So if there's going to be only 1 positive and there could be 2 or 0 negative, that means there must be 4 imaginary roots. So we need to check with the graph to see which is correct. Okay, so putting it into Desmos, we can see that there's just actually 1 root, which is between 1 and 1.5. And we don't have any negative roots. So we're going to have imaginary roots. So to answer this question, describe the possible real zeros of the function. So we can say there's going to be 1 positive real 0 or real root, and there can be 2 or 0 negative roots or zeros.